criteria outlined in the user story. So that's, and then we complete it within the sprint. So the user stories which clear the function test and the acceptance criteria are marked as completed within the sprint, and then we move on. So that build from sprint 1 or the sprint 1 output, we take it up and then use that build for Q3 and Q4 tests. Essentially the negative test, the exploratory test, the full-blown system test, and testing for the non-functional requirements. What we saw as Q3 and Q4. So now what happens is that in the parallel test shown in the orange, for the entire sprint duration, be it 3 weeks, 2 weeks, 3 weeks or 4 weeks, the specialized testers really do the upfront exploratory and non-functional requirement test, and then for that duration. So, and then they actually post the defects which go into the product backlog. So here, while the sprint 2 is going on, this team parallelly tests the software, and then they're not going to really be affected by the sprint dynamics because they are doing it in a parallel fashion in a totally independent environment, which is more likely, which is more closer to production, so that you can really unearth those defects which typically come up in the dedicated test phases. So the advantage is that you are trying to ensure you are able to do these tests early enough, and we are also able to accommodate these bugs what come out within the normal within the sprinting cycles, because these will go into the product backlog, and then these can be taken up in the future sprints. For instance, we take in the illustration shown here, the sprint output of sprint 1 is system tested and NFR tested, and assume there are 4 bugs coming up. These 4 bugs will go into the product backlog and can be prioritized by the product owner to be taken up in sprint 3. So that ensures that whatever the critical defects, major defects which are found early on are really addressed then and there, and they can also be verified in the future parallel test sprints, so as to say. So this ensures that we are able to find the bugs early enough, and all the critical defects are found upfront, and then which can be addressed during the sprinting cycle, so that our dedicated test phases can be really restricted to the minimum level, and then we can have a smooth release at the planned duration. Okay, just to summarize what's the advantage of this parallel testing approach? First is that we are having a stable built and undisturbed time window for doing the right quadrant tests. So essentially, as we spoke, we have given the testers a time window where they can do it without getting disturbed by the sprint dynamics, and then a way in which they get the bugs which are depicted there are addressed. And next point is that any bug found early will go towards avoiding late surprises in the dedicated test phases. And then we are also ensuring that we give a framework wherein the teams which are doing the sprint tests and the right quadrant tests can be groomed for their skills accordingly. As we saw earlier, the testers within the sprint teams have to be really good in using the tools, good in doing the functional tests, good in coming up with the acceptance criteria for the use cases. And then the guys who are doing the right quadrant tests have to be really specialized either in the domain side or in the non-functional requirement side, so that they are able to really do those specialized tests and really uncover these defects. So typically those who are doing the right quadrant tests, I would look at them as being specialists in a particular area. That's what is emphasized in point number 6. So because we are doing a lot of these tests upfront and early, the duration of these dedicated test phases is likely to be minimal, and it's likely to be optimized because you're doing a lot of tests early, and then you can probably do with 1 or 2 test cycles when you're doing the dedicated test phases. And these are often necessary because for compliance related reasons. And then overall, we have the focus is on increasing the predictability of the release date. Predictability in the sense that you are able to really forecast the date, and then the probability of meeting the date is really good enough. Instead of given the background that okay, in the earlier case you are unable to really give a firm date because you find critical defects late in the cycle and you are unable to honor the overall release commitment. Going to the next slide. Okay, that leads us to another interesting discussion on definition of done. So when we look at what we've discussed earlier, we have to talk about what will be the definition of done we need to have for the sprint output. See, definition of done is typically defined as what's the quality of the sprint output we would like to look at the end of each iteration. So as we see here, let us take a simple web application for internal use, say a simple timesheet application. That application, you have a defined set of users and you don't normally foresee too much of technical complexity or domain complexity. And the user group is also well defined, that is going to be within the organization, and the usage profile is also going to be well defined. You can really come up with a clear assessment of what's going to be the projected load and all those things. And then we are also not going to have too much of complexities in terms of what browser they're going to use and things like that. So you can say that technically say that it's going to be fairly easy to say that okay, whatever sprint output is going to come can be production ready. So this is a simple case. Now you look at what's going a typical domain-centric application, web application. So here probably you don't expect too many device or hardware linkages, but it's still external facing web application, and if it is domain-centric, it's likely to have some challenges, and you need to have a lot of external compliances for using this before releasing the software. So you are going to have some level of release level testing which is done. You are going to have some level of independent test phases towards end. So you can say that at the end of each sprint I have a system tested software which has to go certain level of release testing before it goes to the market, before it gets released. Then you have an extremely complex setup, device-centric, domain-heavy, multi-environment, thick client application. So we are talking of softwares which are used in medical scanners, or softwares which are used in complex systems like what's used in the command and control centers for security, softwares which are used in defense systems, softwares which are used in missiles, etc. So these are often difficult to test within an office setup, within a lab setup. So they need to have dedicated field tests and stuff like that. And then putting them to even non-functional requirements test within a sprint is, even parallel to sprint, is extremely complex and extremely difficult. So there, at max, your sprint output could be functional tested. So having a clear understanding of definition of done helps us to clearly know, okay, this is what my sprint output is likely to be. And then you can use that as a basis for really planning your release level test and also setting the management expectation accordingly. So this, stated in other words, this difference between sprint done and being production ready is what is being tested in the hardening sprints. So hardening sprint is again another word for release level test, or another word for the dedicated test phases which I have used. So these are interchangeably usable words, and it's the same gap as what is between potentially shippable and shippable. As you're all aware, in agile terminology, we don't use the word shippable product at the end of the sprint. That's why the people who came up with this framework clearly said it's a potentially shippable increment because of the release level test which we need to do. I think if you have a good understanding of what's the definition of done for your particular project, it really help you plan the release level test and then also help you plan setting the management expectations and risk assessment accordingly. Okay, another area for optimization is managing the test environments. So typically, as we see as we move more towards domain heavy and technology heavy applications, your test environments are likely to be more and more complex. So the idea is that if you are able to have parallel or shadow environments for which the developers can use, then it will help the developers in doing a better developer testing or an informal testing before it is really before it is really packaged within a build and then sent for official testing. Like for instance, you have a dedicated test phase where you have, say, a test cycle which is going on for 3 weeks. So if a developer fixes a bug which is reported on week number 1, he fixes it in week number 1. He did not have to wait for week number 4 to verify it or even to get a first level feedback. So if there's a parallel environment, shadow environment, he can actually deploy it there and then look at informally verifying it, or if it is not working, he can actually see what can be done to fix that problem. So this is again an area where we can potentially optimize. Okay, now if we are going to look at such a team, then we need skill building on these areas. So typically, I would look at skill building in areas of building technical competence, as we've talked of here, as we talked of a lot. We need specialists if we are doing the right quadrant test. Specialists in domain, specialists in technology, and specialists in using tools. So this is very important. So this is what really makes a difference between success of an agile testing initiative and its failure. So if you have really competent people in automation and tooling and in the domain, really you are likely to see a better output here. And then it's also critical that, okay, if India has to really attract high-end product development work, then we really need to ensure that we are really well equipped in these areas. And then of course, we also talk of building self-organized teams in Agile, which means that you have good and capable people in interpersonal skills, in problem solving, being proactive. And then basically we are looking at guys who are professionally mature, who can really be part of a self-organizing team. So these are typically things which are done during organizational agile transformation initiatives. And nevertheless, I thought that this is very important because rarely do we realize that the work output is really proportional to the kind of technical capability that the team has. And then especially in an agile testing context, we expect them to be very strong in using tools in domain and in test automation. So the days of pure manual testers or pure manual testers being as agile testers and then shouldering the responsibilities, I